So today we're going to look at 1.5. Again, that's chapter 1, section 5, and it's describing angle pair relationships. So the first one that we're going to look at is complementary angles. And you're going to notice that if their sum is 90 degrees, they are complementary angles, right? Students get confused between supplementary and complementary. Complementary I think of as two angles that complement each other so well that they are the perfect 90-degree angle. It's kind of like they're the perfect couple, and they form that perfect angle, okay? Supplementary is not a perfect angle. When I add the two angles together, their sum is 180 degrees, okay? So if I take a look at some examples, here's the first one. Notice that I can take 43, I add 47, and they equal what? They equal 90 degrees. Because it equals 90 degrees, this is considered complementary. So they're complementary angles. They add up to 100 or 90 degrees. The next two angles, I'm going to add them up, see what they equal. So I'm going to take 140 plus 40, and that equals 180. Because it's 180 degrees, they're considered supplementary. So that's the difference. Just two angles that add up to the different measures. Now, a couple of definitions. Here's one. One is adjacent angles. Adjacent angles are two angles that share a common vertex and side. So they like touch each other. There's no space between them. So if I take a look at the last two examples that I had, are the complementary angles adjacent or are the supplementary angles adjacent? They are the supplementary angles. So these are considered adjacent because you'll notice they share that same common side. The complementary angles are not because there's a gap between the two angles. The note is when you see angles on a straight line together, they're considered linear pairs. And you can always assume they're supplementary. So if you'll notice that these angles right here, okay, this right here, these angles, right, notice that they form this line. Whenever they do that and they touch, they are considered a linear pair. So on top of being supplementary and being 180 degrees, they're also a linear pair. And we're going to use that a lot when we do our proofs. So having that in your vocabulary is really important. Any questions? Okay, let's move on. Here's some examples. Okay, you're going to notice on these, they're going to ask you to solve for x. So if I'm going to solve for x, how do I go about doing this one? Yes? Okay, I could take 90 minus 61 equals x, right? I could do that. I'm going to spin it a little bit differently. And what I'm going to ask you to do is I'm going to have you take x plus 61 equals 90. And the reason why I'm going to do that instead is because the definition of complementary angles says it's the sum of two angles that equal 90 degrees. This is going to help us when we have proofs. Okay? So you can go, well, don't you get the same answer? Yeah, you do. However, the problem is it doesn't suffice with the proof and the reasoning, okay? Any questions on that? All right, let's go on to the, oh wait, we got to solve for it, don't we? So now we're going to subtract, so x ends up giving me 29, and it's going to be in degrees. Okay? Let's move on to the next one. How do I go about solving for x on this? Yes?
X plus 5 plus 152.
Yes. I'm going to take x plus 5 plus 152 equals 180, and you could say supplementary angles for a reason on a proof. Okay, so now what would be the next step? combine like terms. Now, on your quiz that you just recently had, I had some people subtract 5, and then they subtracted a 152. I'm going to tell you not to do that, and this is why. What happens is let's say that I have a group of markers, okay? And rather than putting them together in a bag and transporting them from one area to the next, I'm going to say, no, I'm not going to bring them all together like combine my like terms and go over and set them down, which would be easiest. Instead, by subtracting them separately, it's like I'm going to take my purple pen and I'm going to walk it over here and set it down. And then I'm going to come back here and I'm going to pick up my red marker. I'm going to pick it up and then I'm going to move it over here. And then I'm going to come back here and I'm going to grab my blue one and I'm going to take it and put it over here. What's more efficient and you're going to make less errors is by actually taking all of that together and combining your like terms before you add it or subtract it. Okay? So I'm going to go ahead and go x plus 157 equals 180. So there's my combined like terms. And then I'm going to subtract it. Some of you on your quiz, you would add this rather than subtract it, and that's why you got it incorrect. So x then equals 23 degrees, and I'm done. Questions? Okay, let's go ahead and move to the next problem. Here's this one. How would I go about solving this one then? Yes? Very good. 5x plus 7x minus 8, and I'm going to set it equal again to 180 degrees. Why? Because they're supplementary. Why? Because they're 180 degrees. Why? Because it's a linear pair. You can say all three. Most of the time on proofs, you'd say supplementary, and you would say linear pair. Okay? All right, so I'm going to combine like terms. I end up with 12x minus 8 equals 180. I'm going to add 8. So I get 188. Then I divide. X gives me 15.6. And is it repeating? So I'm going to put a bar over the top. And that would be degrees. Or I could go x equals 15 2/3. I could also do that if I wanted to. One or the other. They might even have you round to the nearest tenth or round to the nearest hundredth, which some of you did have problems on the quiz. So make sure that you're aware of how to round appropriately, and if not, make sure that you come in and get some help. Questions? All right, let's move on to the next problem. How would I go about this one? (2x plus 3x minus 1 equals, it equals 90, that's correct. And I know that because of this little thing right here. Okay, then I'm going to combine like terms. I end up with 5x minus 1 equals 90. Good, and then I'm going to, yes, 5x equals 91, and then x gives me 18.2. Is it repeating? No? Okay, good. Degrees. Or I could go x equals 18 1/5, I believe. Questions? All right, let's move on to the last page and the last definition. It talks about vertical angles. Now, this is one where students do get confused, and so you want to pay close attention on this. Vertical angles are their sides form two opposite rays, and the angles are opposite of each other. Blah, 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 blah. What does that mean? This is what it means. When I have two lines and they make an X, like you see, okay, I would take angle 4 and angle 2. Do you see how they're kind of opposite from each other? Okay, they are vertical angles. So angle 2 and angle 4 are considered vertical angles. Angles 3 and angles 1 are also vertical angles. They're vertical to each other. So they're like opposite from each other. Very hard for some students to look at and see. They're formed when two lines kind of cross each other and they kind of form the X. Okay, so here's another thing that you need to know about, and this is really important. Vertical angles are always, what does that symbol mean? They're congruent. What does that mean? They're equal. They're equal in measure. So you'll notice in this picture, I already kind of depicted that. Notice that the 4 and the 2 have that 1 hash on it, and the 3 and the 1 have that double hash on it. That's what they mean. I know that 1 and 3 are congruent and 2 and 4 are congruent, meaning they're equal in measure. Questions? Okay, let's go down and take a look at this problem. So it's asking me to solve for x and y, and I need to use algebra. I can't just pull a number out of thin air and say, here it is, see, it works, okay? I've got to use my algebra. So how do I go about solving this for either x or y? What do I do? Use some things that we just learned. Yeah.
2x plus 3x plus 5 equals 180.
Absolutely, yes. She said that I take this angle right here, and I take this angle right here, and they equal 180 degrees. And that is right. The reason is you'll see this line here. You're going to notice that this angle right here and this angle right here, when I add them together, they form that straight line. They are a linear pair, or they're supplementary. So what I'm going to do is come down here and go 2x plus 3x plus 5 equals 180. And you would say linear pair. Okay, combine my like terms. So 5x plus 5 equals 180. And then I'm going to subtract. So 5x equals 175, and x gives me 35. So 35 degrees because it's an angle measure, okay? So I can do that because those two angles are either a linear pair or they're supplementary. All right, now I'm done with that. How do I get y? I found x. Yes, sir.
Put x in 3x plus 5, and then 15y equals 3x plus 5.
Yeah, very good. So this is what he's saying. He's like, well, I can take the 3x plus 5. I know that x was 35 from down there, so I'm going to go 35 plus 5. 35 times 3 is 105 plus 5, so I know that's 110. So I know that this angle right here is 110. Then what he said was, well, because I know that's 110, I know that this angle right here is also 110 because it's a, what type of angle? It's a vertical angle, right? So I can go 15y equals 110. Now what am I going to do? I'm going to divide, so y gives me, what was it? 7.3 repeating like that. Now, you can go, well, Mrs. Medvick, is that the only way to do it? No, it's not. There's another way of doing it. Another thing that you could do is say, well, see that 2x right there? And you see that 15y right there? Don't they also form a linear pair? So I could take that 35, multiply it by 2, and get 70. And 70 plus 15y gives me 180 degrees. And I would get the same answer. You get the same answer. So you've got a little bit more of a choice as long as you're using algebra on how you want to solve those angles. All you have to do is you have to justify it. Questions on these? Perfect. All right, if you have questions, make sure that you ask.